You've probably never talked about measuring angles in any way other than degrees. This is 4.1. 1A. We're going to change 100 degrees into radians. Now, I don't want you to be confused by this. It's brand new and you're thinking, radians, what's radians? You know how when you go to the doctor and you get weighed, they can do it in pounds or they can do it in kilograms, right? There's just a different measurement. You weigh the same, it's just a different way of looking at it. Well, angles are the same way. We can measure them in degrees, which you're comfortable and familiar with, but there's another unit of measurement, which is the radian. Our job right now is to simply change from a degree measure into a radian measure. Just like in chemistry, you change from inches to centimeters. We're going to change from degrees to radians, and it's very, very simple. You're going to do it the same way every time. You're going to say pi over 180 equals radians over degrees. Now, the conversion, just like 12 inches or 1 foot, pi radians is 180 degrees. This is 180 degrees. So pi radians is 180 degrees. So you're going to set up a proportion that says pi over 180 every time, pi over 180. And then you're going to fill in with whatever number they give you, which in this case is 100. And that's a degree, so it's going to go on the bottom. So you're going to say x over 100. This is radians over degrees, radians over degrees. So whatever number they give you, if it's a degree, it goes down here. If it's a radian, it goes up here. Okay? Now, that's a proportion, so we're going to cross multiply. So 100 pi equals 180x. We're trying to figure out x, so we'll divide by 180. So now x equals 100 pi divided by 180, and we're going to reduce that. So remember, if you have zeros over zeros, they cancel. So you can just zip those out right away. And then you have 10 pi over 18, which reduces to 5 pi over 9. Just keep the pi and cancel out your fraction. So the answer to the question is 5 pi over 9.
Can I use the restroom real quick?
Sign out. Now we're going to do the same thing with negative 60. So we're going to set up exactly the same proportion. So pi over 180 equals, pardon me?
I'm just going to pray for this crew.
They don't need prayers.
Well, it's the end of the day on Friday and they're in math.
Tell me what you got on your test yesterday.
You gotta be fun.
Yeah, way to go, Claire.
Yeah. Logarithms. Logarithms.
What about Gabe?
Some of them need prayers.
Yeah, I need prayers. I would love.
You got Gabe the Archangel right behind you. He's got you covered.
I would love your prayers.
I'll pray.
All right, here we go. Pi over 180 equals x over negative 60. You can't get these wrong if you remember pi over 180 and then radians over degrees. Yes, can you take your hood off for me? Thank you. Now, since the number they gave me in the problem is a degrees, it goes in the bottom with the degrees. These are degrees. And now I'll cross multiply. 180x equals negative 60 pi. You're trying to get x by itself, so you're going to divide by 180. So this time we have x equal to negative 60 pi over 180. And we're going to reduce the fraction. So again, often you have zeros on top of each other. So you can get rid of those right off the bat. And then we have negative 6 pi over 18. And you can divide 6 into both of those and get negative 1 pi over 3. So that is your final reduced answer. Don't let the pi confuse you. Just reduce the fraction and keep the pi hanging around there. All right, why don't you try the next one on your own? There's one more. It's 210. Let's try it on our own. See if you can change 210 into radians. What did you say? 7 pi over 6? That is the answer. So see if you can get there. She did it kind of fast. Will you mask up Isaac? And do you know how to start it, Isaac?
Not really, because I kind of missed the first part because I couldn't find my notes.
Okay. Okay, you're
I know.
you still can't find your notes. Okay, they were handed out with this.
I know, they're at my house on my desk.
He's got the proportion. What proportion did you set up?
I got you.
Okay.
So pi over 180 equals x over 210.
Perfect. Everybody okay with that? So now we cross multiply. So 210 pi equals 180x. Divide both sides by 180. Cancel out the zeros. We have 21 over 18, which are both divisible by 3. So that's how we ended up with 7 pi over 6. Now, that takes care of changing from degrees into radians. Look at problem 2. It's the same thing, only we're changing into degrees. These are actually easier usually. Not always, but usually. I'm going to read this up here. What this means, the reason we set this up like this, is because pi radians is the same as 180 degrees. So in other words, this fraction is 1. And then we over here, we want this fraction to also be 1. So we're going to find a match for those. But this is important. Pi radians is 180 degrees. So when I look at problem 2, look at F. What is the answer to F? 180 degrees. Pi radians is always 180 degrees. Period. That will never change. Pi radians is 180 degrees. Now, look at C right above it. Now it says negative pi over 6. Well, first of all, that means my answer is going to be negative. Don't let that confuse you. It just means you're going to have a negative angle. But wait a second. What did you tell me pi was? 180 divided by 6. What's that? 30. So this answer is simply negative 30. I don't have to do anything tricky. I just have to remember that pi is 180. Okay, let's do A. Pi over 4. Now you all know pi is what?
180.
180 divided by 4.
45.
45 degrees. All right, now B, a little bit bigger, 2 pi over 3. Let's not freak out. What's pi?
90.
Pi isn't 90.
180.
Pi is 180. Don't even say that kind of stuff and confuse people. Pi is 180. What's 180 divided by 3? 60. But then I got to times it by 2.
120.
120. Now, you can also do 2 times 180. which is 360, divided by 3 is 120. You can do it either way. You can multiply first or divide first. Let's see, what's left? Oh, D. 7 pi over 6. This is where I like to divide first. So I'm going to take my 180 and I'm going to divide by 6. So what's 180 divided by 6? 30. But then I have to take it times 7. What's 30 times 7? 210 degrees, yeah. Now, E is harder because what is missing in problem E? There's no pi to get started with, right? So to do problem E, you're going to go back to this. There's no shortcut. You're going to have to go back to your proportion and say pi over 180. Now, where is the 2 going to go? In the top of the fraction or the bottom? Top, because it's a radian and you're looking for the degree. When you set it up, it's radians over degrees, pi over 180 degrees. Then you'll cross multiply, so pi x equals 360. Now remember, you're solving for x, so you're going to have to divide by pi. And your answer is 360 over pi. So this proportion can be used to find either R or D depending on what you're looking for. So would you put a box around that? Put a star next to it? All right, now get your calculators out. Those of you that have them. If you don't have one, please pay real close attention. Maybe look over somebody's shoulder. We can't really work together because of the disease, but pay real close attention. All right? So use your calculator to convert the following into degrees, minutes, and seconds. We did F first. F was the first one we did. It's 180. Yep, we did that one first. All right, use your calculator to convert the following into degrees, minutes, and seconds. You know how an hour is divided into 60 minutes?
Yes.
And a minute is divided into 60 seconds? Degrees are actually divided up the same way. So 1 degree is 60 minutes, and every minute is 60 seconds. So if you have an angle, you can, obviously you can say, okay, this angle is 32 degrees. But if you want to be more precise, you could say it's 32 degrees, 10 minutes, and 14 seconds. Just using smaller pieces to get a more accurate measurement of the angle. Those of you that pay attention to like National Geographic and stuff, when they give a latitude or a longitude, they give it in terms of 18 degrees, 40 minutes. Right? They don't just say 18 degrees, they're more precise than that. But anyhow, you don't care about all that. How do we do it? So type 100.4 on your calculator. All right, and then go to second apps. Now, notice that above the apps key, it says angle, right? Okay, look where I'm pointing. It should be colored, apps. Right above it is written what? Angle? So we're going into our angle menu. So press second apps, that's your angle menu. And the very first thing you see is a degree mark. Press enter. So now, oh, I'm sorry, I'm doing the wrong problems. Cancel that. 100.4. Put in 100.4 again. Press second apps. Go down to DMS. We want the degrees, minutes, seconds. So we're gonna go down to DMS and press enter, and you might have to do it twice. But it comes up as 100 degrees, 24 minutes. That little mark is a minute mark, and 0 seconds. Did everybody get that? 100 degrees, 24 minutes, 0 seconds?
How's that measured?
Okay, so what it means is, okay, so let's say we have a circle, like the Earth, and we want to identify this location right here, okay? But it is between, okay, so the Earth is divided up into degrees, so like this is 58 degrees, and this is 59 degrees, and this is 60 degrees, and 61 degrees, and so on around the Earth. But I want to identify a spot that's between 59 and 60.
But there's no like rate, like getting there.
Okay, wait, I'm not sure you're thinking about the same thing. If I measured the length of this room, it might be 20 feet, 4 inches, which means it's more than 20, but less than 21. So I have the smaller unit called inches. This is the same idea. I have to be between 59 and 60. So I need a smaller unit, which we call minutes. So this might be 59 degrees and 32 minutes.
So minutes isn't actually like minutes.
Oh, no, minutes isn't a time. Minutes is a piece of a degree.
Oh.
Yeah,
That's why I was confused.
Yeah,
I
I'm
was like,
sorry.
there's
No.
rate.
lot more stuff.
minutes is a piece of a degree, just like inches is a piece of feet. It just happens to have the same word as the clock.
Got it.
But you can remember it because just like there's 60 minutes of time in an hour, there's 60 minutes of angle in a degree. Okay, so it's a piece of a degree. A minute is a piece of a degree. And then a second is a piece of a minute. So it's an even smaller unit. All right, so to get that on our calculator, we just typed in 100.4 and then went to DMS and that did it. So let's do the next one. 18.375 second angle or apps. Click down to DMS and press enter. And for that one, did you get 18 degrees, 22 minutes, and 30 seconds?
I did.
That's easy. Now, don't let the negative confuse you in the next one. Some angles are negative. It's perfectly okay. So you type in negative 20.42, second angle, DMS, and you got negative 20 degrees, 25 minutes, and 12 seconds.
That's all we did.
That's all you do. When it says use your calculator to convert to degrees, minutes, seconds, that's what you do.
Sorry.
Now, the next set is the opposite. This time you have the degrees, minutes, and seconds, but you're going to get the decimal answer out of that. You're going to change it into a decimal degree. Okay? So we're actually going to use the same sequence of buttons. So start by pressing 132. Then just 132. Stop there. Then go into second angle and hit minute or degrees. Hit degrees. So your calculator screen now says 132 degrees. Okay? So then we type 11. And then go into second angle, and right under the degree mark is the minute mark. See it, the little hash? Press enter. Oh shoot.
No, I lost.
And did you get 132.183?
Yep.
All All right, we're gonna do another one, so hang on, William. I need you paying attention. Let me write the answer down. It's 132.183 degrees. Yeah. All right, so here we go with the next one. If you did not get the right answer, let's do it together. Here we go. Press 18. Now we need our degree mark. So second angle degree mark. And then 12, second angle, and then minute mark, which is right under the degree mark. And now here comes the wildest, wackiest thing you've ever seen in your life. I don't know if you noticed, but there was no second mark in that angle column. Here's how you get it. Press 13. Alpha, which is the colored button right under second, alpha plus sign. Because if you look at your plus sign, do you see the double hash above it? That's how you get it. But on my calculator, it's green, which means it has to come from the green button, the alpha button. So I press that and then enter. And for that one, I got 18.204 degrees if I round off to the nearest thousand.
No, it's not second, it's alpha.
Huh? I'm going through one more problem. Pay attention. When you start working ahead, Mary Kate, this is what happens. You need to stay focused in the minute. All right? So here we go. Please don't breathe on each other, girls. All right, so we're doing problem C now. The negative does not matter. I mean, put it in, it's not going to change a thing. So negative 152 second angle degrees.
Boom. I'm a dog.
And then 18 second angle minutes. So you got to click down to the minute sign.
You bound.
Minute sign.
It's the single hash. And then 39 alpha plus. I have no idea why it's not in the angle menu, but we have to do alpha plus to get the seconds. And that should be negative 152 degrees, or 152.311 degrees if we round off to the nearest thousand. So the new button on our calculator now that we're using a lot is that second angle or second DAPS button. And that has everything we need except the seconds mark, which we get from alpha plus. Okay? All right. Now we've got a different situation. Now we have a circle. And sometimes my writing isn't very clear. This is an S, and it stands for arc length. So this is what we call an arc, right? You know that from geometry. That's an arc. That's S. This is the radius of the circle. And this is the central angle called theta. Theta. T-H-E-T-A. Theta. That's a Greek letter. It's just a variable. Trigonometry was pretty thoroughly developed by the Greeks, and so some of the notation is still the Greek stuff. So instead of x, it's theta. Could be alpha, beta, gamma, whatever. Okay? So we're not going to let that bother us. That is simply a variable. Now, in problem A, they tell us that this angle is 2, and that this radius is 10, and I have to figure out the arc length. luckily, there is a very simple little formula that will find arc length for you. Arc length is found by taking radius times radians. Now that's not the way the formula is going to look in your textbook, but this is how I remember it because it's kind of catchy. Radius times radians, radius times radians. So I know my radius, and I know my angle is 2 radians. So the answer to the question is very simply 20. The length of that arc is 20. It's whatever the radius is times whatever the radian measure of the angle is. Mrs. Ford, how do you know that's a radian measure? Because there is no degree mark. If it doesn't have a degree mark, then it isn't a degree. So I know that's a radian measure. Right now, our angles are either going to be degrees or radians, and if they're degrees, they'll have the little mark.
So where would the mark be if it wasn't a radian?
If it was a degree, if it said 2 degrees, then I would know it's a degree measure. But it doesn't say that, so it's got to be a radian. The next one is exactly the same, except the given is different. So I have the same picture. My angle is 1.5, no degrees, so that's a radian, 1.5 radians. The arc length is 6, and I have to find my radius. My formula is arc length equals radius times radians. Every time I'm doing arc length, that's what's in my head. So let's fill in what we know. We know our arc is 6, and we know our radius is r. I don't know what it is, so I'll call it r. And I know my radians are 1.5.
Yes.
So if I rewrite that equation the way it looks normally on my paper, it would say 6 equals 1.5r. And how do I solve that? Divide by 1.5. So r equals 4. All right. Let's look at the next one. What am I given? I'm given S is 10, so the arc length is 10. The radius is 4. And I need to know the angle. So arc length equals radius times radians. So plugging in what I know, 10 is the arc, 4 is the radius, and I don't know what this is, so I'll just say theta. So 10 equals 4 theta, or 4x. That's just your variable, don't let it bother you. So what's theta? 10 over 4, which is 5 halves, 2 1/2. I'm thinking this is like easy.
Yes.
All right, let's look at the next one.
Might as well give us a quiz right now.
Well, don't say that too soon. Let's take a look at this guy here. Because there's something bad about this problem. Okay? Our formula says arc length equals radius times radians. What's wrong with this problem? Exactly. Don't put 30 in here because that is clearly a degree measure. So the first thing we have to do, before we even go to that formula, the first thing we have to do is change 30 degrees into radians. But we already talked about that. I know you got a lot of information, but look, Daz is going back because it's one of the first things we did, the first thing we did today. Pi over 180 equals what over 30? I need to know how many radians 30 degrees is. So I know pi is the same as 180. So what is the same as 30? So I'll cross multiply. And I'll divide because I'm trying to get x by itself. Always cancel out the zeros. I have 3 over 18, which is 1 over 6.
Yeah.
Would it be wrong to put 1 over 6?
We gotta have pi in there. So 1 over 6 pi would be fine. The 1, it's fine to have a 1 in there, but it's gotta be pi, because it's part of the answer. Now, that is not the answer to the question. Remember, all that did is tell me that this angle is pi over 6. Now I can actually find the arc length. Arc length is radius times radians. And now I have the radian measure. You see why that's a two-step problem? The first step is get your angle into radians. And then the second step is find the arc length. Okay? So, arc length equals 10 times pi over 6. So remember when I multiply fractions, straight across? So 10 pi over 6, does that reduce at all? To 5 pi over 3, yep, 5 thirds pi, 5 pi over 3. And that is the final answer to the question.
Not pi, was the 5/3 on the top or the bottom?
No, the pi must be on the top.
On the top.
Yep. Because when you did your radian measure, it was pi over 6. So that means it's a top number. Okay, one more, another hard one, because look, it's got a degree measure in it. That's always bad news. I know, we can do it though. So here's the scenario. We have a 90-degree angle. We have an arc length of 10 pi, and we want the radius. And we know that arc length equals radius times radians. And we know the arc length is 10 pi. We have no idea what the radius is, so I'll just call it R. You too. And I have an angle, but it's not a radian angle. So I'm going to have to figure out what to write here by changing this into a radian angle. So pi over 180 equals x over 90. this is how we change from degrees to radians or radians to degrees. Pi over 180 equals something over 90. So 90 pi equals 180x.
You're cross multiplying, right?
Uh-huh. Yep, cross multiply. So x equals 90 pi over 180. Now, these almost always reduce. I'm not going to say they do every single time, but they usually do. So the zeros cross out. Now I have 9 over 18. 1/2. So that's 1 pi over 2. You don't have to write the 1, but you can. You got to have the pi. The fraction part's 1/2, but the pi is there. So that's my radian measure. So let me look at my equation now. Let me get it up here where I have some room to work. My equation now is 10 pi equals pi over 2 times r. Radius times radians. How do I solve that?
Can't you multiply the 2 on each side?
Okay, absolutely. We can multiply both sides by 2. So that would give me 20 pi, 2 times 10. And it would cancel that out and I'd have pi r.
Couldn't you just cancel out the pi?
Well, I'm technically dividing both sides by pi.
Yeah.
And yes, that will cancel it out. I'd rather you got in the habit of showing the actual what's happening there. But yeah, they're gonna both cancel. So what's r? 20. So in that section of your notes, I want something starred or highlighted, and that is arc equals radius times radians, right? And then I want you to have a little asterisk up there where it says radians, and make yourself a note. If it's in degrees, you gotta change it to radians. Step 1, if it's in degrees, you gotta change it to radians. Then you can plug it in your formula. Okay? This first section just has a ton of bits and pieces of essential information in it. So, total switch of gears here for number 6. We're going to talk about some navigation because we're going to be doing some problems with navigation. And navigation means directions. Which direction is the ship going in? So, we don't have our books, we do, but we have to waste time getting them out and all that. So let's do this. This is your compass. And when I say compass, I mean the little thing you use when you're lost out in the woods that tells you which direction you're going. I know you have your phones and you press a button and whatever. But in the old days, we actually had to have a tool called a compass to tell us which direction we were headed. So, straight up is north, straight down is south, right is east, left is west. You've probably all at some point in your life looked at a map. Canada's up there, north. Mexico's down there, south. This is the east coast, and this is the west coast. There it is. That's your directions. Now, all those directions are assigned angles. Because if you're flying a plane or sailing a ship, your directions are going to be given in terms of angles, bearings. You probably heard somebody say go on a heading of 162 degrees. So how is that labeled? Well, due north is 0, 0, 0, or 0. You can just use a single 0. South is 180. East is 90. And west is 270. So you'll see a full revolution, 360 degrees. Each quadrant is 90. So this is 90, and this is another 90, and another 90, and another 90, and that makes 360, the full circle. Now, this can be further divided up. So if I were to draw in this line, this would be called northeast. And what would its measure be, its angle measure?
045.
045, 45. You can just put 45. I'll put 045 because I'm in a habit of using 3 digits. Some of the times you have to use 3 digits. But if you put 45, that's not wrong. 45 is fine. And then this one would be southeast. And what would be its measure? 135? And this one would be southwest, right? Everybody following that between the south and the west, so it's southwest. And it would be 225. And in case you're not sure how he's doing that, remember, these are quadrants. So when I split it, it's 45 and 45. So I have 180 and another 45. And then this one would be northwest. And northwest would be 270 and 45, 315. So the quadrants, the black lines, are 90 apart. And then the blue lines split into 45s. Okay, but we're not done because we can do one more split. Actually, you can do more than that, but we're only going to do one more. If I draw in this red line right here, this is called north-northeast. And this red line is called east-northeast. Now, why? Well, the blue line is northeast. When I draw in this red line, I'm on the north side of northeast. On the north side of northeast, so north of northeast. This one is on the east side, so this is east-northeast.
So I'm assuming we're gonna have problems like this on our first quiz. Will we be able to have a compass written out like this? Will that be given to us?
No.
Because this like proves more like your point of how it breaks down like a minute does.
Right.
So we won't be able to have this on it if that.
No, you'll have to, you won't have to draw the whole compass. What'll happen is, like the question A says, find the angle measure for east-southeast.
So we just have to draw those ones
Yep,
in? Okay.
Yep. You don't have to do the whole circle. But if you're doing east-southeast, okay, well, first of all, here's southeast. And then I want to be on the east side of that. So east-southeast would be right here. So this is the angle that you're looking for in the first problem.
Okay, thank you.
Now, what we need to know is that to get to east, we went 90, right? Now, how much more did I go?
22.5.
22.5. How do we know it's 22.5 more? Half of 45. Remember, the blue lines cut this into 45s. So when I split that, this is going to be a 22 and a half, and this is a 22 and a half to make the 45. So to get to my purple dot, I'm starting at 0. So I'm going around to 90 and then another 22 and a half. So that angle would be, if my math is right, 112.5 degrees. 90 and then an extra 22 and a half. Southwest, well, that one I already have labeled. Southwest is this blue line. So that would just be 225. West, northwest. Okay, west northwest. Now here's northwest. Do I want the lower division or do I want the upper division? The lower one, because it's west, northwest. It's on the west side of northwest. So this is the one I want. So I gotta go all the way around to here, which is 270. And then an extra, how much did we say those little pieces were? 22 and a half. So 270 and 22 and a half would be 292.5 for west, northwest. All right, one more and then I'll stop. I think we've packed in a lot today. Oh, actually, no, we'll do one more and be done with this section. North, northwest. Where is north, northwest located? Here's northwest. Wouldn't this right here be north, northwest? So now you can do this a couple of different ways. Isn't that point all the way around the circle except for that little bit right there? So if you wanted to, could you say, well, the whole circle is 360, but I didn't go this part, so could I do 360 minus 22.2? That might be shorter, doesn't matter. So 360 minus 22.2 is 337.5. Now, the other way you could do it is, go all the way around to here is 270, up to here is 315, and then you need an extra 22 and a half, and that would also give you 317.5. Okay, so back to Ella's point, what do I need to know? Well, I gotta know it starts at north. I gotta know that's where I start, that's 0. I gotta know I go this way clockwise. And then I have to know that the main divisions are 90s, and then I can split the 90s into 45s, and then I can split the 45s into 22.5s. All right, one more. A ship leaves port and travels 15 miles on a course of 100 degrees. So I'm going to leave my compass there to remind you. All you're doing is drawing a picture of this guy's course. So here is port, right there. Where would 100 degrees be? It doesn't have to be exact, but approximately, where is 100 degrees? Is it up here?
No.
No. Isn't it down here like this? Isn't this 100 degrees? Because don't I have to get past 90?
Yes.
Right? I gotta get past 90. Now, 100 isn't one of my main, like it's not one of the purple or whatever, but 100 degrees would be a little bit past 90. Okay? And he goes for, where's my paper? He goes for 15 miles. Okay? So now he's here. Now what's he gonna do? Well, now he changes course to 200 degrees. So I'm gonna put another compass here, because now he's starting over. Where would 200 degrees be? Daz is pointing down here, and he's right. Isn't 200 gonna be down here? Because this is 180, and I have to go a little bit past it. And how far did he go there? 2 miles. Oh, just 2 miles. So now he's right here. So, first of all, does everybody understand why that one's shorter than this one? Yeah, we're approximating it, doesn't have to be perfect. Does everybody understand why this first path was going this way, 100 degrees, and then the second path is actually going back this way because 200 means I gotta go past 180, right? So I'm down here for 200, and that's all you have to do is draw the path, okay? Well, you guys have done great. That's a lot of information. 4.1 homework.